Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: STMicroelectronics has announced an industrial MEMS vibration sensor that packs AI processing right inside the sensor itself. Today we'll unpack what that really means and why a sensor that can think for itself could quietly reshape the factory floor. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Think of it like a thermometer that no longer just reads out a number, but decides for itself whether you actually have a fever. So, sit back and enjoy. Here's today's news in one picture. Imagine a thermometer that can judge, all by itself, whether you have a fever. We'll lean on this thermometer all the way through the opening section. Up to now, a thermometer just handed the number to a human. It would say 38.5 degrees, and then it was up to a person to decide whether that counted as a fever. The new kind of sensor we're talking about today doesn't just measure, it makes the call itself, saying this is abnormal or this is still fine, all on its own. Let's stay with the thermometer for a moment. Suppose you had a thermometer that kept measuring a child's temperature the entire time they were asleep. A traditional thermometer would simply keep streaming numbers to the parent. Unless that parent is staring at the screen the whole night, they'd never notice something going wrong. That was the limit of sensors up to now. They could measure, but they couldn't notice. The new thermometer, on the other hand, can make its own decision. Say, sound an alarm the moment the temperature crosses 38 degrees. And it can go further than that, telling apart different patterns: a sudden spike, a slow creeping rise, or a dip that then climbs back up again. Nobody has to sit and watch over it. It only speaks up when something is actually wrong. Why does this matter so much? First, it takes an enormous load off the people watching. Picture a nursery with 100 children, where someone has to keep checking every single temperature all day long. That's exhausting. But if each thermometer can judge for itself, you can flip the whole thing around and only report on the children who actually show a problem. The exact same logic applies in a factory. You might have hundreds of sensors, but they only need to send data out when something genuinely goes wrong. There's one more key point today. Until now, this kind of precise measurement relied on a slightly expensive, slightly bulky, specialized thermometer. The cheaper, smaller kind was always dismissed as good value, but not accurate enough. What's being claimed this time is that the small, affordable sensor has finally broken through that accuracy barrier. From here, let me walk you through what this actually looks like in the real semiconductor industry. Now let's get into the real explanation. What was announced is an industrial MEMS vibration sensor, model number IIS3DWB10IS, developed by STMicroelectronics, one of Europe's largest semiconductor makers. It was announced on June 3, 2026, with availability scheduled to begin in July of 2026. Let me start with MEMS. MEMS stands for Microelectromechanical Systems. Tiny mechanical structures and electronic circuits integrated together on a silicon wafer. The accelerometers and gyroscope sensors inside your smartphone are also a kind of MEMS, so the technology is already all around us in everyday life. This time, that same MEMS technology is being applied to an industrial use case, monitoring the equipment on a factory floor. The biggest feature of this sensor is that it carries an AI processing unit called ISPU 2.0 right inside the sensor itself. ISPU, which stands for Intelligent Sensor Processing Unit, is an embedded processor that can handle the data captured by the sensor on the spot and even run AI inference. Without sending any data off to the cloud or to an external computer, the sensor can complete anomaly detection entirely on its own. This is what we call edge AI, or edge computing. On performance, it can measure vibrations above 10 kHz and withstand shocks of up to 200 G. Factory motors and rotating machinery often produce high-frequency vibration as an early warning sign of failure, so being able to cover the band above 10 kHz is a really important point. Traditional piezoelectric sensors were excellent at accuracy in this band, but they came with the drawback of being expensive and bulky. What ST is emphasizing this time is that it has achieved noise performance and sensitivity on par with traditional piezoelectric sensors. That's a very significant claim. MEMS sensors were always sold on being small and cheap, but on accuracy, they were considered inferior to piezoelectric sensors. ST is saying it has overcome exactly that weakness. That said, this assessment comes from STM itself, and whether it's truly equivalent across every use case will need to be verified out in the field. The intended applications are predictive maintenance and remote condition monitoring of factory equipment. Predictive maintenance means catching a problem before a machine breaks down, so you can carry out maintenance on a planned schedule. A sudden failure that halts a production line is an enormous blow for any manufacturer. By having a sensor detect anomalies in real time and raise an early warning, you can dramatically cut down on downtime. Let me take a moment to lay out the structure of this market. In the market for industrial condition monitoring sensors, piezoelectric sensors have long had a monopoly on the high-accuracy applications. MEMS sensors, meanwhile, spread through consumer devices and general industrial use, thanks to their strengths in cost, small size, and low power consumption. ST's announcement this time carries the potential to break down that division of territory. From my own experience on the floor, whenever a new technology sets out to replace an established one, it almost always gets nitpicked at first. When the CMOS image sensor first appeared, people kept insisting it could never match CCD. When the SSD first arrived, the line was that it could never beat the HDD on capacity and price. And yet the improvements kept coming, and in the end, the tables turned completely. MEMS and piezoelectric sensors may well follow that same road for a while. There's another thing I want to highlight: the meaning of an architecture that runs AI inference inside the sensor itself. As factories become more and more connected through IoT, the number of sensors is exploding. If you send the data from every single sensor up to the cloud, the communication costs and the data processing costs become enormous. By completing the processing at the edge, you lower the network load, improve real-time responsiveness, and reduce privacy risk as well. This trend is only going to accelerate from here. Let me also touch on what the competitors are doing. In the MEMS sensor space, alongside STMicroelectronics, players like Bosch SensorTech and TDK also offer industrial products. The direction of AI built into the sensor isn't unique to ST. It's becoming a trend across the whole industry. You could say ST's announcement marks one milestone in that competition. Let me also check one point from the supply side. Sample availability is scheduled to start in July of 2026, but there's still no clear information on the mass production timeline or the price range. Between a new product being announced and it actually reaching the market, you need a process of yield improvement and quality qualification. This is a point where we'll need to watch for further updates. The IIS 3DWB10IS, announced by STMicroelectronics, is an industrial product that integrates a MEMS vibration sensor with an AI inference unit, ISPU 2.0. It measures vibrations above 10 kHz and handles shocks of up to 200 G. It adopts an edge AI architecture, where the AI inference is completed inside the sensor, with the main applications being predictive maintenance and remote condition monitoring in factories. And the most important claim of all is that it has reached noise performance and sensitivity equal to traditional piezoelectric sensors. If that's truly the case, then on top of the MEMS strengths of cost, small size, and low power, even the weakness in accuracy has now been resolved. With sample availability beginning in July of 2026, we're entering the stage where real-world, on-site evaluation begins. Let me wrap up. What I'm really watching in this product is the claim of a turning point. The claim that it has now caught up on performance, too. When a new technology starts saying of its own accord that it has drawn level with the established technology on performance, that's often a sign that replacement is about to begin. The history of CMOS versus CCD and SSD versus HDD shows us exactly that. Of course, since this is STM's own announcement, we still don't know whether it's truly at parity across every use case. In applications that demand extreme precision, there will surely still be places where piezoelectric sensors hold the advantage. But as a direction of travel, the flow of MEMS slowly eating into the high-accuracy industrial sensor market is, in my view, no longer something that can be stopped. And combined with Edge AI, that flow could accelerate even further. That's all for today. I'll keep bringing you semiconductor news and analysis. So if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.